Hi, this is lecture 3 for week 7 of CS 1030. And we just started looking at how to represent negative numbers. And if you recall, the sign magnitude representation that we looked at in the previous lecture segment very briefly isn't one that's commonly used. And what we're going to do in this segment is we're going to start building up towards the two's complement number system, which is the one that's predominantly used by basically every real computer. So let's get going. Okay, so the basic idea here is to spread the positive and negative numbers over the available representations. And for this particular lecture segment, what we're not going to do is look at binary numbers. We're going to instead look at a fixed width decimal number. And in particular, the fixed width decimal number is going to be 1 digit wide. So one decimal number can represent the digits 0 through 9. And so we have 10 possible numbers that we can represent. And in the regular number system, where we're only representing non-negatives, the numbers that we represent using the digits 0 through 9 are the values 0 through 9. But when we want to start representing negative numbers, of course, we have to choose some of those. We have to give up some of the positive numbers in order to represent negatives, because there's only 10 things we can represent. And the way we're going to do that is we're going to pick half of the available representations to represent negatives, and we're going to use higher valued numbers for that. And then we're going to use the other half of the available representations to represent 0 and the positive numbers. So let's start to look at how that plays out. So one thing we're going to start doing now is arranging numbers in a circle instead of arranging numbers in a line. So all of us in school learned about the number line. And the really convenient thing about the number line is that it extends infinitely in both directions. And this is reflective of the fact that if we keep incrementing a number, it sort of goes off to infinity. It never, it keeps getting bigger. And if we keep decrementing a number, it goes off towards negative infinity. It keeps getting smaller. So a line that's infinite in both directions is really an appropriate way to represent that kind of a number system. Now, the fixed width number systems that we're dealing with in computers, on the other hand, don't keep going to infinity. As we've already talked about, they wrap around. And what helps us think about those better is if we arrange the numbers in a circle. So what we can see here is we've represented the values that can be stored in a single decimal digit, and we've shown them in a circle. So if you take 0 and you keep adding 1 to it, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you add 1 to 9, it doesn't go to 10 because 10 can't be represented in a single decimal digit. It wraps around to 0. Okay, so the circle, putting the numbers in a circle is sort of a very natural way to represent fixed width numbers, and it's something that we're going to do quite a lot. And I would sort of encourage you in your kind of general programming life to think about this as the correct way to represent fixed width numbers. Now, similarly, if we start with 1 and we subtract 2 from it, we can find the resulting value by, instead of moving in a clockwise direction, which we do when we're incrementing, we start decrementing by going counterclockwise. So if we want to take 1 and subtract 2 from it, we go to 0 and pass through 0, and we go to 9. And so 1 minus 2 is 9 on the number circle. Okay, so where does 4 go? Well, 4 goes 4 positions clockwise from 0. So 4 has to go here. So what I'm trying to get at here is that we can sort of arrange numbers however we want, but if we arrange them clockwise and we put 0 up at the top, it gives us kind of a convenient way to talk about fixed width numbers. Okay, so now let's talk about something that's actually sort of tricky. So the tricky thing is, how are we going to arrange the negative numbers? So we already know how to arrange the positive numbers. They start at 0 at the top and they go clockwise. The question is how to do the negative numbers. And what I'd like to convince you of is that probably the most straightforward thing is to put -1 one position counterclockwise from 0. And the idea is that if we can count up by moving clockwise and we count down by going counterclockwise, then this is where -1 has to go. So if we take 0 and we add -1 to it, that's the same thing as subtracting 1. So we go to here. And there's something kind of interesting that happened here, which is that the -1 is always going to go, and this is regardless of the number of binary digits or decimal digits. The number 1 is always going to go sort of at the 1159 position on the number circle, and it's always going to share the same representation as the largest number that we can represent if we're not dealing with negatives. So there's something really tricky going on here, and it's going to, this is confusing even for people who've been doing this for a long time. But the tricky thing that's happening here is the same representation, for example, the decimal number 9, is now going to mean two different things. If we're not trying to represent negative numbers, the digit 9 is going to represent the number 9. And if we are trying to represent negative numbers, the number 9 is going to represent negative 1. Similarly, 8, the digit 8 is going to represent either the number 8 or the number negative 2. And this is only true of negative numbers. The positive numbers, the representation 2 is going to mean the value, the number 2, regardless of whether we're trying to represent negatives. So the sort of weird, potentially confusing thing that's going on here is that when we retrieve a number stored in a computer somewhere, so for example, we find the number 9 stored, we can't tell if that means 9 or negative 1, except unless we sort of have some outside information. And I've been trying to sort of introduce that concept in previous lectures because it's really important, and this is a really common source of confusion. So again, if we just load some number from some memory location in a computer, we can't tell without some sort of outside information whether it was intended to be a number that would have represented negatives, or if it was intended to only use the regular positive numbers. Okay, so let's keep going with that. So if that didn't make absolutely the most possible sense yet, I hope it will soon. Okay, so the 2's complement number system is going to be based on the geometrical idea of a complement, and possibly this is something you remember from high school or grade school. The complement of an angle is the size of an angle that has to be added to that angle to make the largest possible angle. So if the largest possible angle that we're willing to consider is 90 degrees, the complement of a 30-degree angle is a 60-degree angle. Okay, so that's an idea from geometry, and what we're going to do is we're going to carry that over into our number systems. And so let's see how that works. Okay, so the complement of a number x is the largest representable number minus x. So the question is, what's the largest representable number? Well, if our number system is a fixed width number system based on a single decimal digit, the largest possible number, of course, is 9. If, for example, we had if we're using binary and we're using 8 bits, then the largest number would be 255. So hopefully you remember that fact from a previous lecture. Okay, so we always need to know the largest number that's representable given our particular representation choice. So for the single decimal digit that we're talking about for this lecture segment, that's 9. So if we would take the number 4 and we want to figure out its complement, the complement of 4 is the biggest number, 9, minus 4, and that equals 5. So another way to take this equation here is to rearrange its terms a little bit, and then we can get that the number plus its complement always has to add up to the largest possible number. And so now we're going to sort of look at a consequence of that, because what we want to do is sort of learn how to find the negative of a number in the 2's complement number system. So if we have a number 4, how can we negate it? Well, so let's remember from the previous slide that the complement of a number 4 equals the largest possible number minus the number, so that's 5. And so on a number circle, we get 4 plus the complement of 4. 4 plus 5 is 9. But here's the thing. The position of the largest number on the number circle is always going to represent not only the largest number that could be represented if we're not doing negatives, but also minus 1 if we're using the 2's complement system. So 9 and minus 1 are sort of synonyms in some sense. You can think, maybe that's sort of an easy way to think about it. So now let's rewrite our equation so that instead of using 9, we're going to write minus 1. And since they're the same number, we're allowed to do this. So now what we have is x plus the complement of x equals minus 1, because that's just the same formula we had, but we're reinterpreting the largest possible number as minus 1 instead of 9. And if we rearrange that using basically just using algebra, then what we can get is that negative x is equal to the complement of x plus 1. So it's just the same equation as this one, but with the terms rearranged a little bit. Okay, so now we know how to negate a number. We negate a number, so if we want to find negative of x, we take the complement of x and add 1 to it. So if you remember now, the complement of, so let's go back to 4. The complement of 4 was 5. And now if we add 1 to 5, we get 6. So the number 6 is where we're going to represent minus 4. And you can see that that actually agrees with the number wheel interpretation that we had written down. And it's going to turn out that this works sort of in all cases. So again, the negative of a number in a 2's complement number system is the complement of the number added to 1. So basically what this does is gives us a way to, basically we've given a way to find find the negation for all possible numbers on the number wheel. And this gives us basically the basis for a number system. Thanks.